Problem 14. What is the percentage yield of if the actual amount of iron borate is 9.674 grams? Same chemical equation, same molar masses. You need to write down the definition of percent yield. Percent yield is actual yield over theoretical yield times 100. This has to be memorized. I will not give this to you. Actual yield is given. It's given right here in this problem. Theoretical yield must be calculated. Let me continue. So here's a shorter, abbreviated version of that formula. A over T. A is actual, T is theoretical. Remember that we know theoretical is just like the definition we learned a moment ago. Theoretical has not changed. It means what would we get starting with the limiting reactant. So stoichiometry starting with the limiting reactant. To get the theoretical, the T, we have to calculate what we would get of the chemical we're looking for starting with the limiting reactant. Both the A and the T, when you plug it in here, must be the same chemical. So the A and the T must be of the same chemical. This chemical we're looking for, as I read this problem, is iron borate. So both the A and the T must be grams of iron borate. I gave you the actual amount. If you read the problem, you see that the actual amount of iron borate is 9.674 grams of iron borate. Actual amount also could be referred to as experimental. So the A could be E, experimental, what I actually get in the experiment. The T has to be calculated using stoichiometry starting with the limiting reactant, and the T must be also of the same chemical that A was, in this case iron borate. So if we look back to problem 13, we do not know how much iron borate is made starting with the limiting reactant. So we can't just guess, we're going to have to do a calculation. Okay, so we're going to start with our limiting reactant that we established earlier in the problem, and we're going to go to iron borate with a grid. Take a moment, pause the video, and do that. This is what you should have gotten, 20.90 grams of iron borate. So now I've gotten my T because this is how much iron borate was created starting with the limiting reactant. We established this limiting reactant in the first part of the problem. So we're going to plug that 29.90 into the T slot, divide our actual minus our our actual divided by our theoretical, and then multiply by 100. So here is my actual amount divided by my theoretical amount times 100 gives me a 46.29% yield for this problem.